Hey, this is Joel Duff. Welcome back to the Dead Sea Chronicles, part two today. We're ready to dive in and take a closer look at the modern features of the Dead Sea before we start looking deeper into its origins. And we're going to explore today how the Dead Sea is drying up. It's in desperate shape. It keeps getting lower and lower and lower every year. And we want to talk about some of the factors that cause that. And then we want to, and that's going to help us understand how the Dead Sea has changed in the past as well, how it's gone up and down, what factors have caused it to have much higher levels in the past. And that's going to help us eventually get to the point of asking about the original origin of the Dead Sea, like just how extreme has it been in the past. So let's get right to talking about the Dead Sea, the Dead Sea Basin, and its origins. So most of you, I'm sure, think of the Dead Sea as a salty lake that sits way below sea level. It's the lowest point below sea level anywhere on Earth. And of course, you'd be right, though I think there's a whole lot more to it. And I hope that this exploration of this location opens your eyes to a number of other things that are special about the Dead Sea Basin. Because after all, the Dead Sea isn't just a bunch of salt. I mean, it's a very massive and very deep, well over 1,000 feet deep, hypersaline lake that today stretches 31 miles long and 9 miles wide. It's part of a closed drainage basin, meaning water comes in and water doesn't leave. And that basin's between Jordan and Israel. So how should we think about its saltiness? I mean, it's extremely salty. How salty? Well, the Dead Sea contains 300 to 350 parts per thousand salt. And you're like, what does that mean? Well, let's compare to salt water. Salt water is 35 parts per thousand, which is a whole lot more than fresh water, right? So it's 10 times as salty as normal seawater. So this extreme salinity then creates this unique sort of environment that I think has really intrigued people for a long time. I mean, anybody that's gone to the Dead Sea, gotten in the Dead Sea, realizes there's something very unique about that water. And because it's a closed basin, meaning water can't get out of it, that leads to this really dynamic system. Because obviously, if more water comes in than came in the day before, then you expect the water level to rise, right? The sea level to rise. And if more water is leaving, oh, wait a second, didn't I just say that water can't leave? Well, actually, it can leave, right? It can evaporate out, right? So it doesn't run out of the basin, but it does evaporate out of the basin. So if more water is evaporating than is coming in, then there'll be less water in the Dead Sea than there was the day before, and the levels will go down. So you can see how this would be a very dynamic situation, right? If there's a lot of rain, it's the rainy season in the Middle East, then you're going to have the Dead Sea rise, and then it's going to have a dry season, it's going to lower. And then the question we really want to ask ourselves is, what is the net level of the Dead Sea from year to year? And to give away the big thing in this particular part is the net level of the Dead Sea is down, 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 year after year, in a very dramatic and extraordinary way over especially the last 20 years. And we're going to do a little comparison with the last 4,000 years to give you some perspective as to the rapidity of the change of the Dead Sea in this region. Now, of course, people that have come and set their eyes on the Dead Sea historically, I'm sure long, long ago, I mean, people must have wondered where the water came from, right? And where did the water go in the Dead Sea? And yes, ancient thinkers, for example, the Greek philosopher Thales of Miletus, he had this idea that the earth rested on top of water, right? That there was like the crust that we're on, there's water underneath us. That there was, and all the springs and even the rivers, had sources below the earth. I mean, of course, people saw rain, right? And they knew that water came from the sky as well. But there's a belief that the reservoir of the water really comes from underneath the earth. So following this logic, the Dead Sea could have just been connected to some vast submarine sea, right? And that might change its ever-changing volume, right? There's a sea underneath, and sometimes the sea is kind of pushing water up into it, and then sometimes it's draining out into that, that under rock sea that there is. Now, today, of course, we understand the water balance of the Dead Sea a lot differently. right? The Dead Sea doesn't drain away. It, as I said before, it evaporates, right? It evaporates and it leaves stuff like this behind in this picture right here, right? Here's a whole bunch of encrusted salt that has been deposited from on an area close to we're actually very, very close to the shore of the Dead Sea. And so near the shore in these very shallow areas, as evaporation occurs, it's going to cause the salinity of the water to rise even higher than that 350 parts per thousand. And at that point, the salt molecules, right, begin to precipitate, right, come together and form little halite crystals, salt crystals. Those salt crystals will then fall to the bottom of the water column and begin to pile up there. And eventually the Dead Sea, because it's getting lower, is going to expose these salt formations. Or these salt layers. So let's think about that pattern of evaporation versus input a little bit more. Right? As more water gets added, that's going to dilute the waters of the Dead Sea. As it gets diluted, there's not going to be as much salt precipitation that occurs, and there's going to be more evaporation. But as the Dead Sea dries up, it becomes more and more dense. The water becomes heavier, right? With all these different salts, all these different minerals that are in the water. And as a result, evaporation doesn't occur quite as easily in that case. But nonetheless, it will continue. And as it does so, the water just keeps getting saltier and saltier and saltier, and more precipitation occurs. From the earliest recorded observations, it was really evident that the lake didn't just stay the same level, right? Like the shoreline of the Mediterranean. For all intents and purposes, the Mediterranean Sea hasn't changed levels with respect to eyewitnesses over the last few thousand years. Yes, it has changed by, a few inches, but that's not going to be noticeable to any of us. But you could go to the Dead Sea and you could come back each year and you could see like, well, what's going on here? Like this whole area is no longer covered with the sea. And then the next year, all that area is covered and then it's up a higher, and it might change by many, many feet per year in any one particular direction. So as I said in part one, the Dead Sea is an enclosed basin, which is 42,000 square kilometers. And so everything from this dotted line in is where the water flows down, right? Flows down and eventually collects in the Jordan River. And the Jordan River has the most water because it comes from the headwaters of that are in the mountains up here. And that's the place where it's going to get the most moisture, and there's snowfall up there and so forth. Drains down here, Sea of Galilee, all the way down to the Dead Sea, and then just that's it, gets stuck down there. And evaporation is the only way out. And the Dead Sea itself is very, very deep, right? This isn't just a little shallow basin. It's not like, as I showed before, like in Death Valley in California, where there's a very shallow lake at some times of the year. This is well over 1,000 feet, right? Well, 700 meters. That's over 2,000 feet. And we're going to talk about this core that's been taken in the center of the Dead Sea. That's going to be really important to looking at the past, because that's going to show us a record of all the deposited layers, which is going to tell us a little bit about what's happening in this basin. Because what do the layers represent? They represent the stuff that has eroded from the basin and been deposited at the bottom of the basin. And so depending on the changes in the nature of those minerals, the precipitates, and the size of the sediments, that's going to tell us a little bit about what's happening in this basin. But that's for another future episode. This picture, this close-up of some crust from very close to the current shore of the Dead Sea, I think will give you an idea of what's happening here in terms of the sediment that comes down and gets deposited in this basin. So down here you see these white chunks, these white layers. That's going to be your salts, right? Your precipitated salts. And this would have been precipitated and laid down below sea level. So at the time that these layers were laid down, there was water above them. And so what you have is you'd have the rainy season. And during the rainy season, you bring down sediments. And those sediments then get into the water of the Dead Sea, and then they slowly start to fall out, right, and sink to the bottom. And so those sediments then pile up. So these are very fine clay or siltstones, right? Not turned into stone yet, but silt layers. And then maybe you have it becomes very, very dry, right? There's less water input. there's higher rates of evaporation, and then the water becomes saltier, right? And it reaches the point where the salts begin to precipitate out. Then the salt crystals fall to the bottom and they start to form these layers of salts. Right. And then maybe you have another rainy season. Well, that dilutes the water again. It stops precipitation of salts, but then you have other sediments, and those sediments are now piling up there. And so you can get this alteration of layers, which may represent actually annual rings, basically. But they could also represent periods of like dozens or hundreds of years potentially in which there was a lot more water available. So there was no salt precipitation. And then you could have you could have dozens of years in which it was extremely dry, right? In which case you had a lot of salt production. I mean, look at this really thick layer of salt down here compared to the thin layers of salt. And then look at this upper layer up here. All right, this last layer. This would have been when the lake got very, very shallow. Right? It's getting more and more and more shallow all the time. And then as it gets very shallow, you're going to end up with higher salinity levels, right? Because you're going to have evaporation. There's not much water below you. You're going to get really concentrated near the edges of the lake. And then you have a lot of salt precipitation, salts coming out of there. And eventually it's going to dry up. And so maybe there's like little pools, and the pool dries up and it's really dense. And now you get this thick layer of salt on the top. So you get these crusts. And it was showing like this picture right here. Here's this crusty salt. All right, so what about historic water level changes? Over the past century, there's been a really profound shift in the Dead Sea's water balance. Evaporation seems to be almost constantly exceeding the input of new water. And the result is that the lake has shrunk quite a bit. So, for example, in 1930, the surface of the Dead Sea was about 1,280 feet below sea level. That's 390 meters. By 2014, it was 120 feet further below sea level. So 120 feet in 80 years. All right, so 80 years, it's gone down 120 feet. Most of that water loss being just in the last couple decades, right, before 2014. And then from 2000 to 2019 and 2021, we've seen a much more rapid drop. All right, now it's dropped all the way down to 427 or 435 meters below sea level, so 1,420 feet below sea level. And so this gives you a rough idea of, right now, 1,400, actually below 1,400 feet below sea level. And then roughly speaking, sea levels, up here somewhere. And what you have is higher mountains. So I just want you to visualize that, this whole land is, got a mountain on kind of either side of this basin. We're going to talk about the geology of that and why that's the case, how those mountains came to be. But some of them stick up quite high above sea level. So now there were times in the past, and we'll talk much more about this in a future episode, in which the water was much closer to sea level in the Dead Sea Basin. And I'll have to show you the evidence for that to try to convince you that that has happened. We can visualize the recent changes, 1972, 1989, 2011. By the time you get to 2011, you have pretty much a complete separation of the southern basin from the northern basin. And it's the northern basin that's very deep and won't be drying out anytime soon. But the southern basin is pretty much dried out. But now it's used to manufacture various types of minerals from the salt water. So now this, I think, will help us capture the rapid decline. Now, when we say rapid decline, I mean the rapid recent decline, which is abnormal compared to the previous history of the Dead Sea. So this is showing relative heights of the Dead Sea level, the sea level. For the last 4,000 years. Now, I think this is a really interesting figure because, of course, we're going to be talking about the last 4,000 years quite a bit because we're going to go back and look at the biblical record and biblical eyewitness record of the Dead Sea from 4,000 years ago when Abraham and Lot were looking down into the Dead Sea Basin, right, in the Jordan Valley. And Lot was like, yeah, I want to go there. And what did he see? Well, he saw a lake. He saw a valley, right? He didn't see a giant lake filling up an entire canyon. right? He saw the bottom of a valley and springs and places to live. So we know that the lake wasn't terribly high. And we know from a number of other pieces of evidence, all right, other types of data we can collect and other observations, that the lake level was really not that different 4,000 years ago than it was 100 years ago. Really interesting. Like 100 years ago, if you'd been at the Dead Sea, you pretty much were going to be seeing a scene that Lot and Abraham would have seen 4,000 to 4,100 years ago. Probably a very, very similar view, similar climate at that time. But between 4,000 years ago and 100 years ago, there were a lot of changes. It wasn't just always the same. The lake level had gone way down. All right, it had gone down from like 1,240, 50 feet all the way down to more than 1,400 feet below sea level. Way down here where it gets down to over 400 meters below sea level, which is what it is now. It's below 400 meters. And then there's, ups and downs, but it takes 1,000 years for it to fall from, the 900, 100-year level all the way down to 400 below. But look what's happened to us over the last 100 years. It went from what it was 4,000 years ago all the way to what it is today in less than 100 years. And most of this is the last 40 or 50 years. Now, we are going to go back and farther in time. We're going to ask what happened before 4,000 years ago. Where was the lake level then? Were there fluctuations before that? Was it much, much higher? Was it much, much lower? Well, I guess you have to come back for part 4 when we'll talk about just how low has the Dead Sea been, and also just how high has the Dead Sea been. And that's what's going to make our story about how to understand the origins of the Dead Sea so fascinating when we start to compare that to the constrictions that a young Earth creationist viewpoint would place upon the origins, given there's only 4,500 years to explain the entire history of the Dead Sea. So what's the cause of what you just saw there, which is an extremely dramatic shrinkage of the Dead Sea? Well, that is not a natural phenomena. I'm going to say that everything before that, before 1900, is pretty much a natural phenomena going on. A change in climate, a change in the amount of water input versus water outputs that is gradually changing over time. The climate has been changing, and therefore the amount of water in the Dead Sea has been changing. But over the last 100 years, that's not what is causing the Dead Sea to fall. It's clearly the result of human activity. No disputing that. It's very much like the Colorado River. I don't know if you've seen the Colorado River where it exits the United States into Mexico. It's not an impressive river. It's a trickle, a tiny, you can almost walk across it yourself, as opposed to what's going through the Grand Canyon. We're sucking the water out of there for agriculture and drinking water. Right? We're diverting the water away from that. The same thing's happening with the Jordan River. The Jordan River represents the vast majority of the water. 95% of the water that flows into the Dead Sea comes from the Jordan River. But most of that water is now diverted out. 95% of the water of that water is being taken by Israel, Syria, and Jordan. All right, so there's just a tiny little stream that enters into the Dead Sea at this point, and therefore not having a water supply, but still having an arid environment, it's evaporating. There are other things that are going on too, right? It's not just that. There's also that large-scale mining operation that's going on in the southern Dead Sea region. And there, because it's fallen so much, it really doesn't have a natural, the water level is higher in the southern part because they're pumping water basically over there and spreading it out in these huge ponds, right? Shallow ponds, and allowing it to evaporate in order to get bromine and potash and other highly valued minerals out of those salts. All right, so that's intentional evaporation. They're trying to increase evaporation to the maximal amount that they can get it by spreading out as thin and as wide as possible. And so therefore, that's helping the evaporation continue. There's also the effect that the climate has changed in the region. It's clearly a little drier and more arid than it had been 100 years ago. And so that's leading to higher evaporation rates and just less rainfall. So even there are other tributaries or other small amounts of water that get into the Dead Sea from around, but there's just less of that happening as well. So what's the environmental impact of all this? All right, there's a big impact on this area. The retreating shoreline has left what used to be, fancy resorts. I don't know how fancy they were, but big resorts that had been built in the middle 20th century. They're just high and dry, right? They're hundreds of feet above sea level now. And the shore where people used to hang out is thousands of feet. So sometimes you have to walk a quarter mile in order to get to the shore from where the resort was. But a bigger problem is the proliferation of sinkholes. So there's fresh water that's underneath, that's actually, we'll have to talk about when we talk about the geology of the basin, we'll talk about how there's freshwater springs. That fresh water that's actually in the groundwater here and moving toward the Dead Sea. Then what happens when you put fresh water with salt? All right, the fresh water will become salty because it dissolves the salt. And so the salt layers, if there's a thick salt layer below the surface, it'll get dissolved and then you have a pocket there and then it falls down. All right. And some of these are like 60 feet deep. All right. So these are very dangerous, like swallow up whole buildings and, do damage to roads and so forth. As of 2021, there's over 6,000 sinkholes have been documented. And that's compared to in all of the 90s, there were only like 40 sinkhole formations. So that tells you since the 90s, this problem has gotten a lot worse. So it's just not a safe place for human activity in many areas. So since there's been such large changes over the last 50 years, the future of the Dead Sea it's a subject of a lot of scientific study and a lot of growing concern by the countries in that area. There's been all kinds of proposals for, pumping water to the Dead Sea, maybe from the Red Sea, creating some kind of channel, all kinds of creative ideas for maybe buoying up the Dead Sea, recognizing that the economic impact of it getting any lower might be significant. So how low can it go? I mean, it can certainly, if it's another, several thousand feet deep, it could go a lot lower. But it's a complicated formula. It's not like, every day it's going to lose the same amount under the same conditions. What's happening is the lower it gets, the denser it gets, right? The heavier that water gets, the more salt is concentrated in it, which means there's less water, which means there's less evaporation, right? It's harder to evaporate that dense solution. And then also there's this factor of, in the basin, the air tends to get very, very heavy, right? So it can get humid. And the more humid it gets, the more water is trapped in the air in the basin, then that slows down evaporation. So the deeper it gets, right, the more air is kind of trapped down there. Maybe you have storms that are going to blow out the air out of the basin, but the deeper it gets, the heavier the air. I mean, you just have a lot more air above you, right? More dense. It's like if you go to the top of 14,000 foot peak, I can't breathe because I can't get enough air. Well, if you go 1,400 feet below sea level, it's heavy air down there. And so there's a bunch of different factors that modulate the rate at which the Dead Sea can continue to get lower. But clearly, it can still drop another 3-4 feet a year, which is what it's been doing. It's been on a tear the last decade. Almost 4 feet of drying up per year. There's going to be blips in that because, right, once in a while there's going to be extra rain. But nonetheless, the trend line is down, constantly going down. I put this sign, I put this picture of the sign here. Lowest point on Earth, sea level minus 398 meters. But they have to constantly make new signs, right? Because now there's another sign that's like minus 416 meters. And that's a much bigger sign, fancier sign. But now it's 425 meters. Right, so I have to keep it. And then, maybe someday if there's some kind of climatic shift for a few years, maybe all of a sudden it goes up by 20 meters and whatever they built might be underneath water. So it's kind of hard to decide what you're going to do. But this brings us to a really important question. How low can it go? Or how low has it been in the past? I showed you 3,000 years ago, it was close to where it is now. So it's been quite low in the past, but has there been times when it's been even lower? I'm going to show you. I'm going to show you some data that suggests that the Dead Sea has been a lot lower than it is today. All right, a lot lower than it is today. Now, this would be a long, long time ago, and that's going to get us into the whole chronology and get us into like the dating methods and that kind of stuff. So we're going to leave that to another episode. But there has been an extreme drying event, in fact, probably multiple drying events that have occurred in the past. Then you can go to the opposite extent. What if there was much more water input into the Dead Sea Basin than there is today? Well, then you would expect the water to rise. And so in that picture I showed of like the mountainside, it's thought that the water has been at least 700 feet higher than it is today in the past, especially during the last ice age. So during the last ice age, climate was a little bit different, more water input, cooler, so less water output. And so you had had 700-foot high lake in the basin. If you have a 700-foot higher lake in the basin, then you don't have a Sea of Galilee and a Dead Sea. You just have one big giant lake that fills up the whole valley, right? That would be a very different look than anything we have described in the Bible, but we'll get to that in a moment. And how do we know? How do we know that the water was much, much higher in the past? I'm going to devote a whole chapter, a whole part to a whole video to talking about this further, but I'll give you a little highlight right now. There's quite a few studies that have looked at the sides of the basin, and there are clearly terraces along the sides, and these terraces have concreted. They're called concreted terraces. They're concreted because they have minerals, hardened surfaces, right? And those hardened surfaces are the result of that being a shoreline for a long time, right? A shallow water there. And when it's shallow water there, you get precipitation of those salts and other minerals that encrust the material of that on the side of that mountain. And that tells you that, hey, there was a lake here, and this was the shore of the lake. And there's multiple shores. Why are there multiple shores? Because there was times in which the lake was fairly, the climate was the same for a long period of time, and therefore the shore was relatively constant. Form that encrusting agents there, right? Encrusted stuff there. And then maybe climate changes and the water goes up or the water goes down, and then it forms another shoreline. And we're going to look at the evidence of those shorelines from stromatolites and some other things too. What are some of the strong evidences that there were shorelines there? And then there are ways to date like the stuff on those shorelines. So they have a pretty good idea of like, hey, the water was here at one time, and then it was down here, and then the lake was down here, and the lake was way up here at other times. So we'll look at those figures and graphs. The most important question will be, when was the lake much, much higher? And how, ultimately, our question is, how does that fit into the description from scriptures of the Dead Sea Basin? So speaking of the Dead Sea in a biblical context, it's time to do that a little bit. I'm going to do that for each one of these parts of this series. The Dead Sea has a long history in recorded human history, especially in the Bible. I mean, there are other texts outside the Bible that also mention the Dead Sea. But we're going to stick mostly with the scriptures here. And so we see it show up quite early in Genesis. And then it follows through all the way into the Gospels of the New Testament. We see references to the Dead Sea. But the first really significant reference to the Dead Sea comes in Genesis 13. Now, Genesis 13 is a post-flood description of the life of Abraham. And Abraham and Lot get together, and they are surveying the Jordan Valley. And the text there, as I mentioned in the first part of this series, is a well-watered plain, like the garden of the Lord, like the land of Egypt, right? So this also tells you something, right? It tells you at the time that they're speaking, right? At the time this is recorded, which is maybe 4,000 years ago. They had a conception of what Egypt was like. It's well watered because, of course, it has the Nile, right? And the Nile brings floods, which bring the sustaining life to that desert. And then, of course, the Garden of Eden was a land that had been provided with water and had trees and animals and so forth. Don't think tropical, jungle or anything like that, because the land of Palestine, all right, land of Israel, is a land of the promised land is often described as like the Garden of Eden. In other words, God is providing water and they have food and agriculture and animals, right? It's not a people think paradise. They think in like a just tropical paradise with fruit hanging off of everything. You're munching it and it's like warm and steamy or something. In Genesis 13, Lot is looking down into the Dead Sea basin and he sees a place that looks habitable, right? And it is habitable. It's habitable today. There's agriculture in the Dead Sea basin in the Jordan Valley. There are springs there, and we'll talk about those springs. And so there's like oases there. And an oasis is pretty awesome because up near Jerusalem and other areas, that's a pretty arid environment where you're dependent on rainfall. Like there's a rainy season, yes. There's also a dry season. But if you live in the bottom of this basin here, there's like always water. There's always fresh water. So it looked pleasing to his eye. So that's our first glimpse of the Dead Sea. And the glimpse is, although not referenced in terms of like exactly where the Dead Sea is, the Dead Sea couldn't have filled this entire valley, right? Because he clearly saw that there is a river running down through this valley. So then where's the next mention of the Dead Sea? The next significant mention of the Dead Sea would be in Deuteronomy. So here we have Deuteronomy 3:17. This is a description of the promised land's boundaries. And in this description of the boundaries of the promised land, we see a mention of the Dead Sea, right? The verse reads, the Arabah also, with the Jordan as the border from Chinnereth as far as the Sea of Arabah, the Salt Sea. So there's two different names for the Dead Sea, Arabah and the Salt Sea, under the slopes of Pisgah on the east. Well, east of the Dead Sea, which is actually where the Dead Sea, like the actual lake is today and would have been then, that lake is bordered by a fairly tall mountain, mountain range right there, and that's Pisgah. It was an old name of that. And so and you also might wonder, what is Chinnereth? Chinnereth is the Sea of Galilee. All right. So from the Sea of Galilee, as far as the Dead Sea. All right. So you're up from, the north part all the way down to the south, but also on the east side of that, right? Running up to the top of the mountains. That's the edge of the promised land. In fact, that Pisgah is the top of that is thought to be where Moses stood, where he looked out, bringing the Israelites to look out over what was going to be the land that's given to them. Of course, they're going to have to go down. They're going to have to cross the Jordan. So again, we know that the Jordan existed at that time. It was crossable. It must have been running to something. It was running down into the Dead Sea. And then you have a very similar accounting in Numbers 34:3. Your south side shall be from the wilderness of Zin, right? That's in the Negev. And then your southern border shall run from the east, from the end of the Salt Sea on the east, right? If you go down to the bottom of the Dead Sea, that's like basically draw a line from that, and you can figure out the border of this promised land. So then when we get to Joshua, we have the account of the crossing of the Jordan, right? Moses has brought them to the border of the promised land. Right? He has that vision of the land. And then he gives a big speech up on top of that mountain with all the people there. And then he proceeds, and then he dies. He never enters into the promised land. That was one of his punishments for a previous act. And eventually they're led down into the Jordan Valley between the Sea of Galilee and the Dead Sea. So again, we have a marker here showing us that 3,700 years ago, we have a situation where there is something that looks probably very much like it does today. And you have the crossing of the Jordan, right? The waters coming down from above stood and rose in a heap very far away at Adam, the city that is beside Zarethan. So there are There are villages and towns, right? There are known locations where people are inhabiting the bottom of the Jordan Valley. Down toward the Sea of Arabah, the Salt Sea was completely cut off, right? There's a river running down to the Salt Sea, right? And people passed over opposite of Jericho, and Jericho is pretty much on the southern end of the Jordan River, fairly close to the Dead Sea. I remember the Jericho is I'm going to forget now. I should have that in front of me. I think it's 700 feet below sea level. But we'll get to that. That's going to be in another part. We're going to talk about all the different locations, historical locations. And the fact that they're well below sea level, some of them, is very important, especially Sodom and Gomorrah, which might be, really deep down into the Dead Sea Basin. That's going to put a limit on how high the Dead Sea could have ever been in historical recorded history. All right, and then Joshua 12:3 is the accounting of, once again, the geographical boundaries of the Promised Land, but this time it's after some conquests. It says, like, here's the portion of the Promised Land that has been, taken. And so this reflects, again, basically a prophecy from before partially being fulfilled. Right? Joshua 12:3, we find and the Arabah, the Sea of Chinnereth, eastward and in the direction of Beth Jeshimoth, to the Sea of Arabah, the Salt Sea, southward to the foot of the slopes of Pisgah. Right? So he's basically reiterating the same things that Moses said as a promise, and saying, here's the land, all right, that we have conquered. And it's basically this region here from the east side up to the Sea of Galilee around in here. So all of these references consistently refer to the Salt Sea or the Sea of Arabah. I mean, those are two Hebrew terms. And those Hebrew terms, they include the idea of its saline nature, right? That's salty, right? So we know that this wasn't a freshwater body, right? This was known to be a place of extreme salt, and then what does Lot do, right? What does his wife get turned into when she turns to look back and doesn't follow directions, right? It's referred to her being, turned into a pillar of salt, which is very fitting for that particular area. So these biblical descriptions, I think they align remarkably well with what we know about the Dead Sea today. It's a hypersaline lake located in a desert valley. So what's particularly striking about these biblical references is how they portray the Dead Sea as a constant, unchanging feature of the landscape. Not looking at all the New Testament things, but others dispersed. We could look at a number of different passages that briefly mention the Dead Sea or the Salt Sea, and you get the idea. It's there. Everybody knows about it. It's kind of the same thing. Right? There's no drama with respect to like some unexpected event where we have all of a sudden there's a giant lake, that swallows up the Sea of Galilee. No, the Sea of Galilee appears to be very much like the Sea of Galilee from 2,000 years ago, as it is today. So that suggests within the time frame of all of the biblical accounts we have, the Dead Sea's general characteristics and location have remained relatively stable. And that aligns with our geological understanding of the area too. I'm going to show you the actual physical data that suggests, the area hasn't really changed a whole lot over the last 4,000 years. If the Dead Sea had dried up sometime in the past, or if it had been a much larger lake system, then I think that these events would have had to have happened sometime before Abraham. And that's going to be key to all of our interpretations. Everything I'm going to show you that doesn't fit this description, I'm going to show you how the Dead Sea region has been very different in the past, but you cannot squeeze that in between Abraham and the present, or at least Abraham and the New Testament. But then after that, we have other historical records, which will show us that it hasn't changed from 2,000 years ago to present, other than the rapid drop that's occurred recently. All right. So at this point, you might be asking yourself, here's the natural question you should be asking yourself, especially if you're a young Earth creationist, and I'm challenging you with these questions. I'm hoping to get you to think about this, right? But you might be thinking to yourself, well, I mean, I can explain higher water levels in the past, right? What about Noah's flood? right? Surely this could account for at least the really high lake levels in pre-Abrahamic times, right? Make sure you keep that in mind, right? Because we're going to look closely at a whole bunch of geological features in the Dead Sea Rift or the Jordan Valley. And we're going to be asking that question. Is it possible that there could have been a large lake that filled the entire valley, and then it dried down to the Dead Sea, and that left all the salt that's there, right? In other words, did Noah's flood end, and then there was a big valley full of water, and then the way to explain the Dead Sea being salty is like all that water just dried up and it left a bunch of salt at the bottom. We're going to do the calculations, and then we're going to look underneath the Dead Sea, and we're going to find out, there's a whole lot of salt down there. We're going to have to explain more than just a little crust that I showed you today. We're talking about 2,000 feet of salt. We'll figure out how many times would you have to fill up the entire basin and dry it out in order to make 2,000 feet of salt. The Dead Sea serves as a scientific archive. It is. It's a wonderful archive. I'm going to take you a number of places, and we're going to corroborate a number of biblical narratives. That's what I think is really cool about it, is we're going to look at earthquake evidence, and we're going to confirm earthquakes that are mentioned in the Bible. We're going to confirm the climate that is mentioned in the Bible. We're going to confirm what Lot saw with Sodom and Gomorrah, all right, in the Bible, in the evidence from the region around the Dead Sea. All right, it's great. We're going to talk about Mount Sedum, which is a giant, giant pile of salt, mountain of salt at the south end of the Dead Sea, and correlate that a little bit with a biblical reference. Now, I'm going to make this statement right now, and it's going to take me a while to back this up. I don't think the geological record contradicts the biblical narrative at all. Right? Now, we have to set aside the Noahic account, right? You're going to be asking me, and I'm going to be telling you, where in the world does Noah's flood fit in? How would you interpret Noah's flood? How does that fit into the origins of the Dead Sea? What I'm saying is the stability of the Dead Sea's general configuration over the last 4,000 years, which is the most of the recorded history have in the biblical narrative, suggests that both geological and biblical records are speaking reliably. All right. We have reliable evidence that points all in the same direction in terms of the history of the Dead Sea basin. Now, when we step beyond 4,000 years, that's where the questions are going to get, that's where things get dicey. Because that's where we're going to start looking at the Dead Sea sediments, because they're like a giant climate archive. They're going to tell us how the climate has changed over long periods of time. We're going to look at the alternating layers of salt and mud and evaporites as a really high resolution record of past climate changes. And we're going to reconstruct those climate changes and ask, where did 2,000 feet of salt come from? How did the valley actually form to begin with? That's the other big question we haven't addressed yet. Where did this big giant valley come from, and why is it so far below sea level? So the Dead Sea is Earth's lowest lake. I'm going to call it a unique natural laboratory that's going to give us all kinds of insights about Earth's history. So in coming parts of the series, we're going to take a deeper look into the geological processes that shape the Dead Sea. We're going to explore some cutting-edge research techniques that are being used to study it. We're going to consider the implications of that research for understanding Earth's history. And then eventually we're going to turn our attention a little bit more to how we might interpret that evidence in light of models of Earth's history. We're going to do a compare and contrast between young Earth flood geology models and the conventional geological models for the origins of the Dead Sea. Well, we got to wrap this up because we got to move on to what I think are more interesting things. But we just had to set the stage for that by looking at the current situation of the Dead Sea. So coming up next, we've got the Dead Sea Chronicles Part 3. We're going to look at the big picture of the Jordan Valley. Like, where did the Jordan Valley come from? Right? Yeah, there's this sea sitting at the bottom, but like, why is there a valley there? So we're basically asking, why is the whole region configured as it is? Why is there this big deep gash in the earth running from the Dead Sea all the way up north of the Sea of Galilee? And we're going to call this a land that's literally ripped apart, because that's what's happening. We're going to have to talk a little plate tectonics. We have to talk a little bit of rifts and types of rifts, pull apart basins, and uplift. So a bunch of basic geology. We have to do that before we can compare the models of the origins of the Dead Sea itself. So we got that coming up next Monday, part 3. We'll talk to you later. Bye-bye. Thank you for watching this installment of the Dead Sea Chronology series. As we've explored today, the Dead Sea region provides fascinating insights into Earth's history and raises important questions about how we interpret both scientific evidence and scripture. If you'd like to dive deeper into this topic, I invite you to visit my blog, Naturalis Historia, at thenaturalhistorian.com, where you'll find detailed articles exploring each aspect we've covered today, including full references and additional resources. Here's the schedule for upcoming episodes in this series. Each new video builds on what we've learned today, helping us better understand how geology and questions of the Earth's and our origins intersect in this remarkable region. You can learn more about my work and background at joelduff.org. If you found this content helpful, please consider subscribing and sharing with others who might be interested in exploring these important questions about science and faith. Thank you again for watching. Blessings to you and all who are around you.